I'm about to show you in this video lecture on how you should build expressions, capture inputs, and display outputs correctly in C programming language. Hi everyone, Besa Ortuyo here from Caraga State University, and welcome to our second video on review lecture series in C programming language. The purpose of this video lecture is to illustrate how to put together variables, constants or values, and operators to form expressions like arithmetic, relational, and logical expressions needed for integrating formulae and conditions in our program codes. We will also explore the hierarchy of operators, typecasting, and its possible outputs when they are put together. Since programs are created to perform particular tasks or calculations, we will also include techniques to correctly read program inputs from the keyboard and display program outputs to monitor screens. Input-output functions, or what we call as I/O functions, like printf and scanf, will also be covered, and the escape sequence and string formatter to add special effects and formatting to printed output. And lastly, we will have programming exercises covering all those topics so far. Before this video ends, I will give you a tip on avoiding common errors when using incremental and decremental operators, so make sure you stick around. Without further ado, let's start. Operators in C has several categories belonging to different classes. The arithmetic, relational, and logical, for example. Each of these category of operators has their own type of associativity. This means operators within the same category is grouped from left to right, or from the right to the left, in the absence of parentheses. The table presented here has a total of 15 categories, arranged from the group of operators with the highest precedence, the postfix group, to the group with the lowest, the comma group. The postfix group contains the pair of parentheses, the incremental and decremental operators, among others that you already have used previously, the pair of brackets of the array as subscript operator, and the arrow and the dot operators of structure to access its members. With the given examples on the right side, with C equals A plus B times 2, the multiplication operation with the highest precedence here will be evaluated first, followed by the addition, then the assignment operation. The second expression is actually the same with the first one, except that it explicitly grouped b times 2 with a parenthesis. The third one is not the same as the first one, since a plus b was associated first with a parenthesis, and it yields value 10 rather than 7. These examples show the postfix incremental and decremental operators. With C equals A++, the compiler will assign a value of A to C first before performing the incremental operation. This is because the compiler interprets this code to C equals A followed by A++. The same situation goes with the second example. Thus, the values of C will be 3 and A will be 4 for the first expression, while on the second expression it would be C equals 2 and B equals 1. The second category of operators is the unary group. This group of operators acts upon a single operand to produce new value. This means you can use a unary negation operator to have a negative number. Say A equals 3, then negative A yields negative 3 value. Other operators under this group are as follows: unary plus, logical negation, one's complement with a tilde character, prefix increment, prefix decrement, typecasts, indirection that operates on a pointer variable, the address of operator, which is the ampersand, that takes the address of its operand, which is commonly used in scanf functions, where the captured input from the keyboard is stored on the address of the operand A, for example. And lastly, the size of operator that computes the number of bytes of a given operand. like size of A that yields a value 4 as the number of bytes the integer operand A has. If you're going to evaluate size of char or size of character, it will give you 1 corresponding to the number of bytes the character type has. Observe the unary incremental and decremental operator. Both values assigned to C and A are the same. This is because the compiler performs first the incremental operation since it is prefixed with A, and whatever the result to A will also be stored to C. And same goes with the third example, having the decremental operation. The next groups are from the arithmetic operators, the multiplicative operators with higher precedence over the additive operators. Please pause the video and try to answer the following examples. Did you get it right? Good job! But if not, try to scan through the provided answers and check where you missed a spot. The fifth category is the shift group, with the right and the left shift operators. The shift operations perform shifting digits to the right for the right shift and shifting digits to the left for the left shift. This operation applies to the equivalent binary value of the number from the left operand, where the number of the shift depends on the value on the right operand. To clearly illustrate how the shift operation works, direct your attention to the given examples. Our first example here is on the right shift operation. Say we have an integer number 13 of 2 bytes, is subject for the right shift operation of 2 counts. Each digit of the binary equivalent, as shown in the diagram, will be shifted or moved 1 count at a time towards the right side. So you have that is twice, while the leftmost end will have additional zeros to complete the sequence. So this makes the least significant digit 1 shifted out, resulting in series 110, which is actually integer 6 for the first shift, while on the second shift with the same operation resulting to series 11 or binary 11, which is actually the equivalent of 3 in integer. This next example here illustrates the left shift operation. We have the same integer number 13 that we wish to be shifted to the left in 3 counts. So with this equivalent binary number of sequence 1101 contained in a 2-byte or 16-bit size, each of these digits will be shifted or moved 1 count at a time to its left side 3 times. And the rightmost digits will be filled with 3 zeros as well to complete the sequence. The first shift results to sequence 11010, so you will have an integer 26 for that. And on the second shift, we will have the 110100 and the integer 52. And for the last and final shift, it will result to 1101000. So that would be the integer 104. To make the shift operation much easier, doing the right shift with n counts, just discard the n rightmost digits like 1101 after the right shift of 2 counts becomes 11. And with the left shift with n counts, just add n zeros to the rightmost position, like what we did also with the example 1101 with 3 counts for the left shift becoming 1101000. Okay, this time, pause the video and try to answer this self-check corner before you proceed in viewing the result. Did you answer all items correctly? Great! Now, let's proceed with the remaining operators and expressions. The next categories are the relational, bitwise, logical, and conditional groups, all with different levels of hierarchy. Please direct your attention to the following examples, with expressions having a mixed type of operator group. Can you guess what the value each expression would give? You may pause this video to evaluate the expression given and play it back to check whether you get it right. These are the answers to the expressions given. How are you doing? I hope you got it all correctly. Showing you here is our example on bitwise and unary complement operator. As you may have observed, those operators perform an equivalent binary number of the given values. With the bitwise AND operator, it checks each bit on the same index of both operands. Per check will provide a bit 1 if both bits from the operand is 1, otherwise 0. Thus, with the given example with integers 10 and 28 as binary 10, 10 and 11100, resolve to 1000, which is actually integer 8. The fourth digit has the only value 1 since the bits of its operands on the same index are both 1. Moving on with the bitwise OR operator, it also checks each bit of the same index on both operands. If either of the bits is 1, then the resulting bit is also 1. But if both bits are 0, then the resulting bit becomes 0. Taking a closer look with the example given, the second to the fifth indexes from the right resolves to 1 since its corresponding operands has at least 1, 1. If bitwise AND gives 1 if both bits are 1, and bitwise OR gives 1 if either of the bits is 1, the bitwise XOR will only give 1 if the bits are either the pair of 0, 1 or 1, 0. Otherwise, it gives 0. For the two's complement, I will leave it to you as a reading assignment. Our next example is on equality and conditional operators. The question mark and the colon operators of the conditional is used as a pair where the question mark indicates that the preceding clause is a condition, and the succeeding is performed if it yields true. The colon operator, on the other hand, signifies the else part, so when the condition is false, this will be performed instead. Take a look at how the condition operators work similarly with the conditional statement. With x equals 1, the display would be 1 apple in a basket, while when x is equal to 2, the display becomes 2 apples in the basket. Notice the s on the apple is added. So if you wish to use the conditional operators rather than the conditional statement, make sure that the expression is simple enough and follows the given syntax for writing. Here is our last groups in the hierarchy of operators in C, the assignment and the comma group. The assignment group contains all operators in a combination of the assignment operator, like the plus equals and the times equals. In each pair of operators, the left operator is performed first, then the assignment operator. You may put it this way. With plus equals, for example, it means add first, then assign. Like with the example C plus equals 1, where we add 1 to the value of C, then we give the result back to C. If you have noticed, the given examples here are equivalent expressions, the C++, C equals C plus 1, and the C plus equals 1. The comma operator is used as a separator. It could be a separator during variable declaration or a separator like in printf and scanf, separating strings from variables, constants, or expressions. In summary, we have 15 hierarchical groups of operators, where the postfix has the highest precedence and the comma as the lowest. Okay, this point in time, please pause the video and try to answer this self-check corner on operators and expressions before you proceed in viewing the result. Did you answer all items correctly? Good job! Now let's proceed with typecasting.